don't mind you will say on the way. Yes, he set up the audio. I did not mind you play the video. Honestly, I can't decide.
Friends and colleagues, so we are going to start the afternoon session momentarily. So please return to your seat.
I prefer the safer one. I prefer
So you want to ask unless this orbit video? Okay, so we're gonna open this video for if you want, we can.
もういいですよ。この人たちは。上司に呼び出されて、あと3時半に戻ってきます。彼はちょっと、会議がある。はい。あともうちょっと。Okay. So in this afternoon, we're going to jump into the technologies and policy aspects of the life cycle management of fluorocarbons or refrigerants, including the used refrigerants collection and destruction. And to start, we are going to have twofold sessions and in between we have coffee break. But because in the we are starting a little bit later, so that we're going to have a couple of presentations regarding the collection of used refrigerants. And without having group discussion before coffee break, what we are going to we're going to start with the destruction part. And to start, I would like to invite Sakaguchi-san. He's with us today, and he's going to talk about his activities regarding the used refrigerant collection network.
I am called Sakaguchi from E&D Solutions. Sorry. E&D Solutions is environment consulting firm in Japan. We are a subsidiary company of Dowa Ecosystem since 2001. I would like to introduce past performance associated with refrigerant management promotion in Thailand under MOEJ project. as case example of efforts to create a used refrigerant collection network. This slide shows our company's past performance associated with refrigerant fluorocarbon management in ASEAN countries. Since 2013, we have been conducting the study and project to promote fluorocarbon management in ASEAN, including Thailand, supported by MOEJ or other governmental agencies. At first, we are focusing recovery and destruction to prevent fluorocarbon emission as greenhouse gas GHG, especially in Thailand. We were involved in JCMF gas project, destruction model project from 2018 to realize fluorocarbon destruction in Thailand, utilizing BPEC in Bampu Industrial Estate. You will visit BPEC tomorrow afternoon. Other than destruction, we have been focusing leak prevention and reclamation by introducing Japanese experience. Since 2021, we have been involved in MOEG project associated with fluorocarbons life cycle management in Thailand and Malaysia. This slide shows our activities for awareness raising under MOEG project. We have seminar on fluorocarbon management and demonstration activities such as recovery destruction in Thailand and other countries. This slide shows other MOEG projects in Thailand. Waste management, Siam, Doha ecosystem, and E&D solutions have been engaged to promote fluorocarbon destruction at BPEC. Destruction at BPEC contributes GHG reduction in Thailand. For your information, Mr. Nishimura, Ministry of the Environment, visit to BPEC on January this year. Fluorocarbon destruction in Thailand has been realized utilizing knowledge and experience in Japan, such as destruction with waste incinerator and recovery during used air conditioning unit recycling. I'd like to introduce summary result of MOEG project in Thailand last year. MOEG project covers 6 countries, including Thailand. Project team consists of OECC and E&E Solutions, and E&E Solutions is in charge of project in Thailand and Malaysia. Main object is to support to accelerate fluorocarbon emission prevention through life cycle by using policy knowledge and technology in Japan. MOEG project in Thailand consists of 2 parts. Part 1, Part 1 is cooperation with government agencies for future policy support. Part 2 is support on fluorocarbon management network with private companies in Thailand and Japan. This shows concept image of future fluorocarbon management network in Thailand. Fluorocarbon management network consists of technologies such as leak prevention, recovery, reclamation, and destruction. And policy support is important to promote fluorocarbon management. That's why we are emphasizing public and private cooperation between Thai side and Japan side. Numbers in pink hatching are covered by this MOEG project. Task 1 of part 1 is support on preparation of HFC inventory. last year, we had a seminar, a webinar with ONEP and DIW to introduce methodology of HFC inventory. Task 2 of part 1 is a support on introduction of fluorocarbon life cycle management. We had a webinar with DIW and TGO and introduced Japanese experience on refrigerant management in climate change mitigation measures. TGO also made a presentation on activities related to carbon neutrality and net zero GHG emission in Thailand. Task 3 of part 1 is assistance to diffuse of certification system for servicing technicians. We had a seminar in Bangkok last year and introduced refrigerant handling technician certification system in Japan. Also, we brought introduce actual recovery machine and other related equipment with support of Ichinen Tasco. Under part 2 activities, refrigerant leakage detection using ultrasonic detection system and IoT. This is Freon Keeper was installed at supermarket in Thailand last year. Proper maintenance technology is very important to prevent leakage and operate refrigeration equipment. Energy saving and GHG reduction can be accomplished by leak detection, repair, and periodic inspection. This slide shows relationship between the amounts of refrigerant leakage and increase in power consumption. In case of 30% refrigerant leakage, power consumption is increased up to 60%. In other words, prevention of leakage is very important because it can save energy consumption and GHG emission. We just started this year's MOG project in Thailand. Contents of MOG project in Thailand are continuing program and almost same as last year's. And we'll have some events such as seminar and demonstration in this year. Okay. Thank you very much.
Takako-san, thank you very much. I think maybe in this session, we can actually receive questions and answers, and maybe with the next presentation, which is going to be delivered by Mr. Sakamoto from Ichinen Tasco, so that together with his presentation, we're going to have a sort of like a technical questions and answers. So the next one is Mr. Sakamoto, please. Okay.
Hi, my name is Yukio Sakamoto of Ichinen Tasco from Japan. We are a distributor of air conditioning tools and fluorocarbon recovery machine in Japan. In Japan, we offer training sessions for operations in order to make the fluorocarbon recovery process safer and more efficient. Since fluorocarbon is a high pressure gas, it's necessary to have prior knowledge and to operate the equipment correctly. Here, we would like to explain about on-site recovery machines and accessories, as well as equipment that alerts us to gas leaks during operation of refrigerant and air conditioning equipment. This is a recovery machine for on-site use. It's about the size of a handbag, and the weight is about 10 to 20 kilo. The price of the machine is about 200,000 Japanese yen. Of course, in Japanese case. The price, I'm sorry, it's powered by a 220 volt power supply on site. In addition, a cylinder, a charging scale, gauge manifold, a charging hose, and other tools are required. These items. As shown in the figure on this page, it's connected by a charging hose from the other unit of the air conditioner and packed into a cylinder by the compressor of the recovery machine. There is also a charging scale to measure the weight of fluorocarbons recovered from one unit, and an analyzer used when reclaimate of fluorocarbons. We will show you a demonstration of the operation of the analyzer and the recovery machine tomorrow. The fluorocarbon recovery unit is similar in structure to an air conditioner, consisting of a compressor, condenser, and fan, and is portable, easy to carry, and safe to operators. These are accessories for efficient recovery. These include oil separators and cooling units, which are used as needed. These are cylinders. There are different types of cylinders ranging from 5 liters to 100 liters, with 10 and 20-liter cylinders being used primarily. They also contain a float sensor inside to stop the recovery machine when the cylinder is just before full. Sorry. These are nickel-plated coated cylinders suitable for fluorocarbon reclamating are also available. Safety device. The top of the cylinder has a lead stopper that melts when the temperature reaches 60 degrees, releasing the gas inside. The recovery machine also stops when the pressure reaches 3 MPa. A fluorocarbon analyzer. It analyzes the purity of fluorocarbons recovered from the market. Fluorocarbons with poor purity are not reclaimed but sent to destruction. And next, I would like to introduce the From Keeper from a manufacturer called Number. This is a Japanese maker. This is a device that monitors fluorocarbons leakage during operation of refrigeration and air conditioning equipment. When the refrigeration system is low in fluorocarbons, bubbles form, as can be seen in a cytograph. Sorry. Like this. This is normal phase, slight leakage through bubbles, and massive leakage. Here is 50% outside. Pass. From keeper detects and graphs ultrasonics caused by foam generation. And also, from keeper uses the internet to send data to the administrator. When an abnormality is detected, the graph rises like this. The graph can be displayed in hourly, daily, or monthly units, giving an indication of the state of the chiller. Here is an example of the large Japanese supermarket. The front keeper allowed the company to detect leaks early and repair them, bringing down the electricity bill by 25.8% here. While it's difficult for even skilled technicians to detect the slightest gas leak, but the front keepers can detect leaks at an early stage, enabling them to reduce the amount of front leaks and take action before significant damage is done to the refrigeration system. This is a handy leak detector. This product has a capacity of less than 5 grams per year to detect leaks and help you check where the leak is located. From now, please watch the pump down video on the end. This is a process of trapping fluorocarbons in the outdoor unit of air conditioner. When recover fluorocarbons, relocating or removing air conditioning. Although it's a very simple process, there are many cases where the fluorocarbon is released into the atmosphere without a pump down. It's very important thing. Please show. Thank you very much. It's very easy, but very, very important. Doesn't know how to pump down. Yes, very easy. Please remember and go back to your country. Thank you.
Thank you very much, Sakamoto-san, and also Sakaguchi-san, earlier presentation. So, how did you like it? Well, with the technical aspects, I think it's important to understand for the from the safety nature. I think what this is very important, but also the avoidance of the leakage. And also the proper destruction. That's important. Perhaps so, if you have any technical questions or maybe arrangement type questions, well, you're welcome to raise one or two here. Also, of course, well, we are inviting Asian colleagues, but also we have many Japanese people who are regularly talking to among ourselves, but they have questions probably, so that yeah. Any questions or any comments? Okay, Professor Etono. Okay.
Yeah, you teach us to how to handle for the gas, but because of this gas is not maybe burn or bloat, because of it's not dangerous gas to the I think it's difficult to control the people who manage the gas because of if leakage there is nobody knows that is a gas is leakage, and then yeah, the operator itself maybe can do everything. Then we have to give a knowledge that is the danger is not directly but for atmosphere maybe.
Okay.
Yeah.
それがポンプダウンできないので、配管がつながったまま、リカバリーマシンに回収。
So if it's if it's broken, well then you simply we cannot pump down the gas, so that the entire machine will be removed, and then they're collected for for fixing. So that's the way what they are going to deal with.
There is instrument to control the gas.
Yeah.
Is it leakage or not? Yeah, because of if we rely on the people who manage this gas, then it might just leakage because of we cannot see it.
Okay. So,
Yeah, okay. So I
Professor
need
Ying
to
is-
explain. I need to
please.
explain something about the pump down, because so you know that the pump down the refrigerant is flow to the condenser. We call that it is the outdoor unit. Okay, so therefore it is not dangerous. It is safety. Okay, so I agree, but I need to add information, because so if we collect to the larger cooling capacity like a VRV, like a anti, it is a pump down solution is very effective. Yes. Okay. So don't worry about the flammable or safety. Okay.
Okay.
I
Thank
explain.
you.
Yes,
Thank
I need to
you.
explain.
Okay.
Because
Thank you.
so in Vietnam we are doing that by pump down. Yeah. Okay. For not only for room air, but for the VRV, for the chiller, it is a very big cooling capacity. Okay. No problem.
Thank you
Yeah.
very much.
Yeah. Okay.
Any other? Okay. Okay, good. Thank you very much. So that we can also come back to the presentation later. Okay, the next one. Well, so we have seen the technological aspects of the collection and also this destruction. Then now we would like to see the further arrangement of the to create an enabling environment to prepare for introducing collection technologies. And for this, I would like to invite Kasai-san for the presentation. Thank you.
Good afternoon, everybody. I'm Kasai. I participated to this seminar since 2020. I was working for Japanese Environment Ministry until 2018. In 2000, I was working for legislation of Japan fluorocarbon regulations. Then today I feel heavy responsibility to introduce today's climate change. And now I feel a little cold in addition to air conditioning in this hotel. Next slide, please. I and other member country, for example, Tasco Daikin MZ, Iwatani, Taiyo Shoji, and Gemba Next consist of Fluorocarbon Global Reduction Promotion Associations. This this association, in order to realize global greenhouse gas emission reduction. Thank you. Excuse me, this name. Global reduction on the Earth as a whole. The proposal or request to government to reduce fluorocarbon emission globally, or similar regulation global reduction of fluorocarbons or metals, and coordinations to build fluorocarbon excuse me, fluorocarbon collection, reclamation, and destruction network. I prefer collection rather than recovery because collected fluorocarbon cannot be used directly. It's include contaminants or different mixing ratio. Then this network sum up the amount of collection, reclamation, and destruction, CFC, HCFC, and HFC, CO2 equivalent ton, or support destruction of ODS in Asian countries. At present, we built fluorocarbon network, Vietnam, Thailand, Indonesia, and Malaysia. We wish a lot of local companies in Asian countries to take part in this network. Next slide, please. The feature of this network, collecting COC, CFC, HCFC, and HFC from factory, warehouse, large commercial facilities, hotels, and so on. The reclaiming collected refrigerant, which can be reclaimed, and destroying that cannot be reclaimed. In order to realize sustainable use of fluorocarbon refrigerant and global environment conservation. the claimed refrigerant achieve the same quality as newly product refrigerant achieved Japan industrial standards, later explained. The collecting fluorocarbon not only from large-scale facility for business use, but also from electric household appliance or car air conditioner at the collection site of discarded these products if possible. And using our IoT system that consists of cylinders attached QR code and smartphone. This is open source reflex developing by Gemba next to Mr. Ashish. After my presentation, he explained these systems. This system based on each stage of operations and sum up the data amount of network. And reflex can be customized to meet the need of each country. Then I emphasize not only HFC, but also CFC, HCFCs, so-called ODS. The international fluorocarbon regulation is divided to treaty. Then there's a loophole missing emission of CFC and HCFCs. Morning session, the defense of UNFCCC and Paris Agreement and Montreal Protocol was explained. Then I think destruction of CFC or HFC is a high value of real negative emission. The many countries miss to this situation. Many countries should recognize the importance of the additional contribution because destruction of CFC and HCFC is besides of Paris Agreement, but it had strong influence on global warming. Next slide, please. In this viewpoint, we are summing up total amount. The convert to CFC equivalent to GWP 100. And this is the most important thing in my presentation. If each country government to issue a thanks letter or certificate of our network, our member companies operating fluorocarbon network can describe the contribution of GHG emission reduction, including ODS, additional contribution. And our association has allocated 2 billion yen to support the destruction of ODS in this fiscal year budget. For example, this fund could be used to set the free destruction amount to increase the operation of destruction facilities. It is now under consideration. Next slide, please. This is a draft example thanks letter. Our association, member countries. This is a result. The weight and CO2 equivalent ton. Thanks to your network activity that conducted to collection, reclamation, and the destruction of strong global warming gas, fluorocarbons. Our country contribute to reduce global warming gas emission in our country. I appreciate your activity. It means this reduction amount are not transport to Japan. Our member country contribute to directly your country's reduction. Next slide, please. This is a difference of reclamation and recycle. Reclamation is using this distilling system. The difference of temperature separate fluorocarbons and contaminants. Then it keep a high quality. Next slide, please. This is a system, distill system. Next, please. And this is this quality standard, mixing ratio, purity, non-condensable gas, moisture, acid, aberration residues. MZ ビナは岩谷reclamation facility fulfill these standards. Next slide, please. This is an important point, correction. It's necessary to times. If 5 minutes, only 60% to correct. If operating 20 minutes, near about 80%. Then, and operator should observe fluorocarbon pressure absorbing point to certain pressure. To check this pressure, correction very few, very little amount. Then supervising this correction action is very difficult. Then we emphasize the curve suggests to that economic incentive is necessary. For example, corrected refrigerant pays the cost according to the weight. For example, next slide, please. It is an example of incentive correction operator. In Malaysia, Taiwan Corporation's Jagas project, collected fluorocarbon reclamation facility pay this cost. For Australia, operator bring collected fluorocarbon destruction facility to this 10 Australian dollar per kilogram. This this is paid by fund collected which levy which importer or detailer paid imported. The incentive paid by kilogram stimulate operator to collect more fluorocarbons. The Australian government finance initial running cost 3.5 million Australian dollar to the product corporation. This is at the first stage. Our next slide, please. 時間は大丈夫かな。 This is a method of cost sharing. Home appliance, Japan has a home appliance and commercial use different system. The home appliance, the user pays recycling cost, including fluorocarbons, to add to appliance discarded. The user. The commercial use, the law spread that the filling and collecting operator can demand the user to pay fluorocarbon collection, reclamation, and destruction cost, and the user should pay demanded cost. It is adequate. There's a various type of refrigerator and conditioner. Amount of fluorocarbons are very different, and the transportation cost is depend on the region. Different. The service price is fixed by negotiation between user and the operator. The regional average price are open, but there is a price not compulsory. Next slide, please. The automobile, there is a base fluorocarbon cost deposit. They check the payment at the inspection, at the car inspection. The initial period after enforcement, the user discarding the used car before inspection should pay the cost at the same time. Next slide, please. The cost paying alternatives, user charge expended to producer responsibility, levy on import income, sale of reclaimed fluorocarbons. What donation? Our proposal donation. The carbon credit. Next slide, please. I explain present situation of each country's networks. The Vietnam collection route using member country Daikin Vietnam plant and service network. They appeal to Japanese companies other than Daikin, the cooperation of share, which has cooperated with the JCM fluorocarbon destruction project. The reclamation facility is a MZBNA, Mr. Mizuhara's subsidiaries. The destruction facility, there are some destruction facility such as TT company in Hanoi at HEPCO in here, which is under construction. Then we are looking for adequate destruction facilities, preparing for fluorocarbon law, put into enforce on 1st January. Next slide, please. The tracking system, we used to the next last year's project. The collecting the we plan to expand the and customize request to meet Vietnamese needs. The cost burden, based on the fact that facilities a certain size or large will be required to collect or recover fluorocarbon gas from equipment on January 2024. The such cost be borne by the owner or user manager of this equipment in accordance with the Japanese law. Next, please. Last network, Thai, Indonesia, and Vietnam. These three are member company established. Next slide, please. The Thailand, the basic policy, decommission will be set up in the site of Yatani next year's January. From November, operation started. Now conducted field work to build network collection reclamation, reclaimed refrigerant sales. Cannot be reclaimed, should destroy. This is a schedule of the end of this year. Next slide, please. The relevant activity. The task collaboration with air conditioning manufacturer. The demonstration of Fluorocarbon. Next slide, please. Indonesia. Indonesia also, Yatani started to January 2024. Next year, the same schedule. And same next is plan to use. Next slide, please. The relevant activity are almost the same. The PR, the activity of network to Indonesian related to ministry and agencies. Next slide, please. The Malaysia. Malaysia, now we are trial operation is now. The PR is necessary. The schedule on PR training. And JACA project. In this JACA project, pump down is conducted. The destruction facility is now under negotiation quality alarm. They also next is planned. Next slide, please. They now ongoing. Next slide, please. This part I'll explain next to destruction presentation. Thank you.
Thank you very much, Kasai-san, for the nice introduction of the ways and means for that can realize the systems to ensure the collection of used refrigerants. Yeah, and then also our interest is how we're going to facilitate for the collection of used refrigerants instead of just releasing into the atmosphere. We would like to collect, and also we would like to reclaim and recycle, and also for those which are not useful, then we're going to destroy with the incineration plant. So, but for this also, we need to see how these used refrigerants are actually treated. And then this requires sort of like a transparency measures. And for this part, I would like to invite Mr. Ashish, who is actually working on this electronical system development introduction. Yes, please.
Greetings, everyone. I'm Ashish Busi, founder and CEO of Gemba Next. So firstly, thanks a lot to the Ministry of Environment, Japan and OECC for giving this opportunity. Very quickly, I'll probably take 10 to 12 minutes to walk you through RefNext. So RefNext is a complete one-stop solution, like Kato-san mentioned, for the centralized recovery, reclaim, reuse, and destroy of HFCs, HCFCs, CFCs-based refrigerant not only at any certain stage, but across the complete life cycle. So this helps corporations to even achieve their carbon neutrality as well as earn carbon credits. So thanks to today's session, I got to hear a lot about each country's initiatives. And especially in the challenges, I observed that there are a lot of common challenges between the countries. So there were a lot of keywords about cooperation or connection between stakeholders, especially in the private sector, reporting to the governments, then technician training and management of know-how. There was a monitoring of the movement of the ODS across the entire life cycle, especially issues with data gathering, data collection, usage of the data, MRV, as well as life cycle tracking and database, including HFC and ODS banks. So probably you will find a lot of the same keywords in my presentation, especially how we are coming up with a solution to realize this. So very quickly, I mean, management of refrigerant is the need of the hour. I mean, with the Kigali Amendment, about 70 billion tons of equivalent CO2 is going to be released into the atmosphere by 2050 if we do not manage it. So HFC is phased down, and the management of refrigerant primarily has 3 steps: safe recovery, safe recovery, safe storage and handling, and safe disposal. Now, this seems to be just 3 simple steps, but just to give you an example of Japan, I mean, how difficult it is. In Japan, the law has been there for the last 20 years, but unfortunately, recovery rate has been lesser than 40%. The Ministry of Environment has been targeting for 70%, and we have identified what are the key reasons for this low recovery rate. So especially the low recovery rate is due to the limited spread of the know-how or spread of the recovery knowledge to a lot of technicians. Second issue is the shortage and inefficient use of cylinders. So there are cylinders, but where that cylinder is, who is having it, how much has been recovered, all of this data is not there. Then lack of collection and storage facilities, as well as the connectivity. I think like the presentation by the person from Cambodia also had mentioned, there is a lack of connectivity between stakeholders, recovery and recycling facilities, recovery and disposing facilities. Then there is a lack of purity tracking, and most importantly, lack and spread of know-how and advocacy. This is precisely what RefNext as a complete one-stop solution is helping to overcome. So what we have done is, in this process, there are 11 stakeholders in an evolved market like Japan. And this is where I think all the Southeast Asian and Indian countries are also going to go to. So these are your installers, contractors who do the recovery. Very important, the customers and equipment owners who own buildings, who own hotels, they also need to be aware of the sustainability requirement. Real estate developers, transporters, collection centers, refrigerant manufacturers, maintenance companies, disposers, recyclers, dealers, and most importantly, AC or equipment manufacturers. So what we have done is we have brought all of them onto one single platform. Think of it, what Uber has done for taxis and users, we have basically done for all the stakeholders in this business. So once all of them got connected, as a byproduct, we were able to complete the cycle, the circle, and as a result, we are able to realize the circular economy. Now, because of the circular economy, the workflow is flowing, and as an end result, the very important value proposition we are given to real estate developers, owners, is the fact that because of the reuse of reclaimed refrigerant as well as visualization, it has become very clear that their carbon footprint has reduced by 7 times, essentially directly contributing to their carbon neutrality 2050 goals. So this is what we have visualized. How are we exactly doing this? I think we have seen a lot of images from Sakamoto-san's presentation also about cylinders. These cylinders are going to be a key in this whole process of monitoring. RefNext has basically connected the 6 steps. The step 1 is recovery from customer, then judgment and storage at collection center, reclaim and destroy. Then in step 4, what we are doing is we are checking the purity and registering the purity of reclaimed refrigerant, then reuse of reclaimed refrigerant, and finally filling of the reclaimed refrigerant to the customer. So we manage the complete hierarchy of customer, building, equipment. Once it is recovered, all our cylinders are tagged by QR codes. So we are able to simply scan and register the recovery data. So we are very much simplifying the on-site tasks of dealers and contractors. So it becomes very easy for them to actually execute this job, and they do not find it very heavy. Once they have recovered, just like you order from a restaurant on Uber Eats, as simple as that, contractor can request a collection center to come and pick up the recovery cylinder, or they can go and drop the recovery cylinder, which is then transferred into collection cylinders, which is again tracked on RefNext. Then at the reclaim step, once the reclaim is done, we are registering this data through QR codes onto the app again, and even the destroy amount. So as a result of these 3 steps, we have completely achieved the tracking and traceability from the recovery building right up to recycle, reclaim, and destroy. Now, after the reclaim, so destroy step gets completed here. In case of reclaim, why this process is very important is when we want to reuse reclaimed refrigerant, as we all know, we need to validate it to the customer. So generally we all have this feeling, right? Second-hand goods are not good. I mean, if I can buy a new t-shirt, why would I go and want to buy a second-hand t-shirt? So this level of advocacy is also required with a lot of customers, that reclaimed refrigerant is of the same quality, same level, and it is not going to reduce the efficiency of your equipment. So in order to do that, RefNext basically registers and certifies reclaimed refrigerant purity. Now, with this purity and this certificate of purity, we then transfer the reclaimed refrigerant into smaller fill cylinders, which are then sent back into the market. And the same set of users, it's your same customer, building, equipment, dealer, and contractor. What refrigerant was recovered is now filled back into the machines. So this helps to complete the whole cycle. And in this process, at every stage, we have given the app. So data is being registered and certifications like the reports for each job is being generated automatically. So what this does is these contractors, dealers do not need to go back to the office, enter any data into Excel sheets, and then report to the governments or report to the customers. So very quickly, along with the life cycle of refrigerant, what we are doing is we are also managing the life cycle of the equipment. So especially for equipment owners and building owners, every time an equipment is installed, whatever refrigerant has been put into the equipment or it has been recovered from the equipment, we are basically tracking that. And again, the refrigerant put in, whether it is a recycled refrigerant or a virgin refrigerant. So this helps governments also to track how much of fresh virgin refrigerant was used as against the reclaimed refrigerant that was used in the market. Now, with each recovery and each fill, basically, we are also tracking the refrigerant amount and the equivalent CO2. So this helps at any stage for us to identify what is the equivalent CO2 emissions that are possible if it leaks from this machine. So this data at the end, I mean, through the complete life cycle, is useful for the governments and the Ministry of Environment to basically grasp what was the initial refrigerant amount in the machine, with each servicing what was put in, what was taken out, and whether it was virgin or recycled. So this essentially is helping to realize the ODS, HFC banks, and this tool can directly be leveraged by the governments to track this across the complete country. Very quickly, what we have been doing for the last 1.5 years and why we have the confidence to support the solution in the Southeast Asian countries is, over the last 1.5 years, starting from Jan 2022, we released this product into the market. We have a total traction of about 461 tons of refrigerant that has been recovered and tracked on our system, out of which 226 was recycled, 192 tons was disposed. So this recovered refrigerant calculates to about 884 million kilograms of equivalent CO2, which is about 6% of the Japanese market size. So we have validated the product in the Japanese market. We are growing there, and we would like to provide the advantages of what we have learned while developing this product in Southeast Asian countries as well. This is the actual screen grab of the product. So this is the web app and the mobile app. So all the dealers, contractors, and rest of the stakeholders can use the app from their PC at office, or on the site, on the Gemba, they can use it from the application. This is one screen grab of RefNext, which basically gives a real-time tracking data of the refrigerant amounts. So for each refrigerant type, we are just tracking, the recovery amount out of that, what was recycled and disposed, and with the GWP, what is the equivalent CO2. We are also giving insights to the customers, manufacturers, that, the recovered refrigerant, it was supposed to be recycled, but when it went to the collection center, it was judged as disposed. So this gives insights to contractors, dealers, that, the know-how is still not up to the mark. Maybe they are not using the right tools. And this can help the manufacturing companies or dealers to go to the site and basically increase the training of the technicians. This is the last feature I'd like to talk about. the data accumulation, we are not just tracking the numbers, but we are also giving a visually easy to understand dashboard, especially for customers, with the intent of tracking the carbon footprint CFP, equivalent CO2 mitigation, using this data on their ESG reports, and ultimately for claiming carbon credits. So what we basically do is for any customer, let's take a real estate company that has multiple buildings, a portfolio of buildings across the city. What they can do is across the different cities or states, they can filter out which city, which pin code, which particular building, and which equipment. And this is going to be the complete data set of related to the refrigerant for that particular building or equipment. Now, when you flip this card, on the back side, what you can see is the history data that I just talked about. So we are very specifically helping customers to track at a building level and at an equipment level at the time of installation, at the time of maintenance for the equivalent CO2. Now, this data can be leveraged by the customers in their ESG reports. Ultimately, we are also creating a carbon project on behalf of the customers to leverage this proof, the data proof that we have here to help them acquire the carbon credits. And for the ministries of environment and the government, this becomes the base data which gets reported back to them in terms of like what is the basically what is the stock of refrigerant that is available in the market. So that was a short and quick introduction about RefNext. At the end, what I would like to mention is this system has been running in Japan for the last 1.5 years. Now, this has been built based on the Freon law of Japan. However, what we intend to do is we have created a flexible base system that covers complete stakeholders. Now, we do understand that each country has its own specific requirements, and our objective is to work for the environment at the end of the day, because across the earth, we need to reduce the CO2 emissions. So we are very flexible in how we can customize the solution for each country's needs. So we just want to become the platform and work potentially with each government to make the solution a best fit for each country in the way they want it. And we would like to roll it out with the support of the government. Thank you so much.
Thank you very much, Mr. Ashish. Maybe we would like to entertain a couple of questions before going into the coffee break. Anyone who wants to raise the question, well, please go ahead. Okay, Professor Retino. Okay, you can whisper.
Yeah, is it possible to add information cost recovery? Because if we change some of these gases and then we know how much is it?
Yes, ma'am. We are also thank you for the question, ma'am. So I understand you mentioned if we can add the cost of the recovery on the system. So we are also managing the cost of the refrigerant and the cost of the service that is required to do the recovery. And at the end of the life cycle, we are also managing the cost of the reclaimed refrigerant at the point of sale, at the time of sale. So as a feature, we are having that feature. In Japan, it's just that we are not using it right now, because individual players are leveraging their own costs that's in the market. Ultimately, we want to become like a marketplace of services and refrigerants. So that feature is available. Yes. Yes, ma'am. Yeah. So for the equivalent CO2, for every ton of equivalent CO2, essentially we would be able to get 1 carbon credit, which depending on each registry, for example, ACR, American Carbon Registry, each carbon credit is about $3.8 to $4.5. So we are able to track the number of carbon credits on the platform. Yes.
Thank you very much. Another question. Okay, Prince-san.
I also have questions to RefNext. Sorry, my name is Prin from WMS Doha, Thailand, and yeah, I see you got a quite successful in Japan. Like you got like 6% of entire market, which yeah, everyone know that like Japan is the biggest market for the refrigerant. That's such a big number. I think it's like the number of 3 or 4 countries together. And I have questions like how many users that you have already. I saw in the slide, but yeah, is that actual number? So I have the question to that, like, what is your biggest struggle during you like try to make it happen, and how long that you can get that number of customers?
Thank you so much. I think thank you for appreciating the effort that went into getting that number. But yeah, like you're absolutely right. I mean, 6% is a very big figure for us to have achieved in the last 1.5 years. In terms of the number of customers, the way we worked was we had a very good, strong partner, which was Daikin. So Daikin has been working with us to help us with the on-site Gemba for testing, trialing the solutions. Daikin Japan is completely onboarded onto RefNext. 80% of our refrigerant tracking happens for Daikin. 20% is third-party customers. So that is how we were able to initially get that big push, big number. And now Daikin is a market leader in terms of manufacturing companies also, and especially pioneering this whole refrigerant management process. So with the brand name of Daikin, we had many other brands also join us through word of mouth publicity. So we are not doing any marketing or sales activity. It is through the popularity of the application in Japan that we are spreading. I hope that answered your question. Okay, thank you so much.
Thank you very much. I have a question to
Yes, Kato-san. Yes, please.
So you introduced, you explore the potential application of this RefNext or similar tracking system as a countrywide system. This is a very big thing, but that we're now, as you know, we have started working on this in Vietnam in cooperation with Ministry of Natural Resources and Environment, Monre, together with my friend Ian. Another question is you mentioned a company's level or a building owners, sort of a real estate group level, so that if companies are having holding maybe 5 or 10 buildings, there in Bangkok there are many real estate developers. So this system can also be useful for that kind of group. About for example, subnational level, like a local government or like a provincial level, or something. For example, one government wants to do like a designated pilot area, and then apply this just to test whether these are useful in their context. For example, I don't know if Indonesian government wants to apply this but not entire country. It's quite big, but maybe only small region in Jakarta, for example, or Bogor, even smaller region. But is this applicable in that kind of like a pilot thing too?
So thank you, Kato-san. To very simply answer the question, exactly, it is the exact same feature is applicable for any region. Just to give you an example, the way we collate or do the data reporting, there are different types of admins. I mean, people who can view the data. One type of administrator is a building owner or a customer. One type of an administrator is a regional administrator. For example, there is a ward, then there is maybe a city level, there is a state level. So depending on which level of an administrator you are, you would be able to view that scope of data in the same way, in the same format. So precisely like you mentioned, if we want to do a pilot for a small region, that can be visualized in the exact same dashboard.
I see.
Yes.
Okay. That is very
just to
interesting.
add on to the point, like you mentioned, the building owners. So real estate companies do have their portfolios. One other big type of users that we see, and especially you mentioned about Indonesia. So we recently have been working with Marriott Group, one of the largest hotel groups there in the Bali region of Indonesia. So they have their ESG targets. So these kind of hotel groups are another big player who have a large facility of buildings, who want to see this data across their building portfolio and then report it to their Asian headquarters in Singapore or their headquarters in the US, that this is how they have been contributing to reducing the ESG and carbon footprint of the company as a whole. So I think there are many interesting use cases for this dashboard.
I see.
Yeah.
That's interesting. So I think I know there are many. Well, we've been working with many private sector in Thailand, and then I think there are kind of like a many franchise type business, and then I think now I can see this is quite applicable in their context. Okay, thank you very much. Okay,
Thank you so much.
Okay, I think a discussion should continue. So that we're going to have a coffee break until 3:20 sharp. Then we're coming back, and then after the coffee break, we're going to have the next exciting presentation from actually Kumprin from Doha Ecosystems. So he's talking about the kind of like a preview type presentation about the destruction of collected fluorocarbons or refrigerants, which we're going to visit tomorrow. Okay, so please return to your seat by 3:20. Thank you very much. Enjoy your coffee and conversation. Thanks.
So we start. Okay, so we will start at this one. So usually people come from this time, right? The rules are clear from down from 3. Okay, so then we just make sure that we keep checking if it's already there. If it's late, then probably have to speak up.
real-time dashboard where we have like a big space So people separate this private data right now the data is complicated but we have got the data so we make sure that private customers, private users of this will share this public
3:40. 3:30. Yes, that's why I just want to have a like small violin. I think it's kind of like raspberries, probably something like sour. I think it's like looks like a tab.
Okay. Ladies and gentlemen, we're going to resume our discussion. So please return to your seat. Okay. Now we had that exciting session regarding the collection and destruction, and also the establishment of sort of like a network of stakeholders. Then we are also in the same context, so we would like to dig into our discussion about how we're going to process at the end of life stage. And then for this, we have a presenter from Dowa Ecosystems. And now I would like to invite Kumprin.
Hello, everyone. Okay. Yeah, first of all, it's my honor that I have a chance to explain about what are we doing in Thailand and what are we trying to do in near future in Thailand. Like this today from like MOH and OECC, we have always worked together about this. And also there are some like companies who currently work with me. Thank you for your always cooperations. So I would like to explain about what are we doing. Our company name in Thailand is Waste Management Siam. We are under our parents company called Dowa and Dowa Ecosystem. Today, I would like to explain you about the destruction technology we use in Thailand, which is like the one that we adapt from what we are using in Japan right now. There's a lot of there's a lot of presentation today, which I think you have quite good clear pictures about our refrigerant like life cycle. Like the previous presentation, which like the Gemban left next, he have show you a really good ideal pictures of everyone need to be connected together in order to like move to next stage together. So our part is like the destruction technology. So that is, I would like you to understand how important of this destruction technology is. First of all, let me explain about what is Dowa Group doing. Like we are a Japanese company. SOB is like more than 100 years already. And we actually have like 5 group company, which can divide it into like a lot of contribution in the industry. We have Dowa Metal, which is produce metals and kinds of low precious metal raw materials, and we supply those to the industrial. We have 3 companies who are like manufacturers into equipments, into parts which has been used for the industry. And after the end of life of those equipment, we will collect those back. We do the recycle. We do the like I call it the waste management, which we do both recycle, we do the destruction, we do the treatment, the intermediate treatment, and the final disposal. So this kinds of like cycle business is what we are currently doing right now. In Thailand, we also do the like similar thing, but in like smaller scale. And yeah, we have branches around the world. We have branches in many countries in Asia, such as China, Taiwan, Myanmar, Singapore, Indonesia. We are trying to expand around Asia. We also have some kinds of office in Europe and in the States as well. And yeah, but most of our current like abroad activity is located in Southeast Asia. That's why this project is very important for us. And this is the main business of, as I mentioned, we not do only recycling. We also do the treatment. We also do the disposal. We also do the remediations, which is like after you finish kind of utilize of the land or the things, you need to also make it like with non into like non-hazardous land to be used for the next stage. We also do those things, and we also do logistics of this business. And this is what we have in Thailand. Mainly we have 3 plants. The one that related to this project is Bang Pu Environmental Complex, or BPEC, that the place that you're gonna like have visit tomorrow. And yeah, we have the incinerator here, which can like incinerate both non-hazardous and hazardous. And we also have the Eastern Seaboard Environmental Complex, or SBEC. This one we have the landfills. We also have the like alternative energy blending process. We also have like kinds of WTE, like electronics waste dismantling and recycling right there. And we have like a small plant in southern Thailand in Songkhla province that we like we do the decontaminations of the equipments that come from oil and gas company, and we have the logistic to transport all the waste from all over Thailand. We actually have customer all over Thailand from many sectors, but most of the sectors come from like the industrial sector. We do have some waste from the municipality, which also treat in like similar plant. Talking about the main the main character for this one is our facility in Bang Pu, Samut Prakan, Thailand, the incinerator. We have the capacity of the solid waste, something around 150 tons per day. And we also can treat the liquid waste there. Talking about the refrigerant, we can treat, because there is no such regulations in Thailand, how much we can treat. So we actually reference from what we done in Japan, which allow us to treat something around 3% of the solid waste. And nowadays we use about 0.6% of solid waste, which can convert into something around 900 kilograms per day. So we can say we have the capacity roughly around 300 tons or 250 tons per year. And in this system, we treat the refrigerant together with other waste. It means that, for example, we gonna use the solid waste come from municipality and industrial. And on top of that, we also feed the refrigerant together and to treat and use the same system to like detoxify it. And in Thailand, this is one of the like complex thing in Thailand. We have many ministry and many departments which manage their own waste. For example, this is the example. There's the Ministry of Industrial, and they already like define the refrigerant as the hazardous waste, which have to be treated correctly under the law of Ministry of Industrial. And they're like this series, like the numbers of each waste that has to be controlled under the Ministry of Industrial. But on the other hand, if you're talking about the refrigerant that come from, let's say, the home appliance, but come from the household, come from the hotels, come from the like the municipality sectors, doesn't cover in this regulations. It will be covered in the regulations of the Ministry of Health, I think. So this kind of like there are many systems in Thailand which manage all the waste. So it's quite hard for everyone like to manage all the refrigerant to different system. And what we have done is that we, as I mentioned, we reference the Japanese technologies, and we like approach the Department of Industrial, and we have chance to do the experiment to treat the refrigerant in around 2015. And yeah, the important factor for the refrigerant destruction is the factor called DRE. Sorry, this was in Thailand. Like it's the destruction rate efficiency. This shows that how much you can destroy refrigerant to your system, which we can get for 99.99% under our system. So utilize this result, we get the official treatment permit from Department of Industrial, so we can use that. And yeah, I mentioned about this, so I'm gonna skip this part. And on top of that, we also work with Japanese MOEJ through the JCM project around 2018 to 2021. And what is the most importance of this project is that this project is actually connect us together with other stakeholders, because we are just, in Thailand, we're a very small company who do only the refrigerant destruction. But in order to get those refrigerants, we need to we have do the recovery from the industrial, from the household, from many sectors. We also have to service to transport those in different permit, different regulations. So that's kind of complex happen along this project. But because of this project, we can somehow achieve the very good result. And in 2019, we destroy around 5 tons of refrigerant. And yeah, at the end of the project, we can destroy around 50 tons of refrigerant. And yeah, I don't have the actual number. I can give you some numbers that this year, I think we successfully destroyed something around 100 tons of refrigerant. So it's growth doubles every year, and we think we can get more and more numbers in the future. Yes, I call it success, but it's actually the first step of this refrigerant management in Thailand. And yeah, this is what I have been told to you, is that the complex thing about working in Thailand is about the regulations, because in the blue area is the refrigerant that has been managed under the Department of Industry, but in the green area is refrigerant which has been has been managed under Department of Health. So it's totally different regulation that need to be controlled, and totally different documentations that you have to report to the regulators. And there's about to be a new regulations to manage for the home appliance and electric equipment, which will be under the MONRE, the Ministry of National Resource. So it's going to be another story for these pictures. So it's very important, for every sector to work together and trying to connect and works under each regulators. And yeah, that's why not only the destruction part, we works a lot with a lot of regulators. In this case, we work with the Department of the MONRE to trying to establish the new laws of home appliance. We actually the vendors for them to do the dismantling in our site. We also work with the manufacturers of the home appliance, and we get some samples for them which we do the dismantling. We study about the overall cost, and there's some mention in this morning about the cost sharing things. So that kind of thing has been calculated through the process, and we report this to MONRE, and we wish they will use some of our data and trying to establish into new laws. And not only the B2E, we also work with the automotive manufacturers in order to establish similar law in automotive sector as well. So this kind of thing is always been our works around this year. So yeah, in summary, as I mentioned, we may successfully destroy some amounts of refrigerant, but if you're talking about thousands or even several 10,000s of refrigerant has been imported to Thailand every year, we are just 0.1% of those refrigerant. And what I can share to you is we have 80% of market share of refrigerant destruction treatment in Thailand. You can see the big gap between that in order to get the more successful in the near future. So that's why we will need the cooperation from every sector, the municipality, the industrial, as well as the regulators, in order to establish such the network that can link everyone together and work in the same pace. So thank you so much for my presentation.
Thank you, Prince-san. Likewise, the earlier session, we're going to have another session, another presentation. Then after that, we're going to have questions and answers session. Okay. The next presenter is participating online, and Mr. Anderson, Stephen, are you there? Okay. Can you hear me?
And I can hear you fine, and the video looks very sharp.
Okay. Good morning. Okay, so Stephen, well, you can start your presentation, but could you introduce yourself first? I haven't explained who you are yet, so that here in Bangkok we have something around like 40 to 50 people from governments, private sector, etc. So we would like to welcome you to Bangkok virtually.
Well, thank you very much for inviting me. It's a great pleasure to join this important workshop. I am Stephen Anderson, and I'm best known because I was the founding co-chair of the Technology and Economic Assessment Panel, and I also was the chair of the Solvents Technical Options Committee and many other of the special reports for over 20 years or so. I also was the deputy director for stratospheric protection for the United States Environmental Protection Agency. So I had a double life, one life at EPA and one life at the United Nations. Today I'm presenting on behalf of myself and two colleagues, Richard Tad Ferris and Shapu Sun from the Institute for Governance and Sustainable Development. This is an NGO that concentrates on questions of sustainability and also access to new technology. We're strong advocates of the Kigali Amendment, the energy efficiency, and of course, we are hoping for a full replenishment of the multilateral fund. So the messages I have are very clear, and I've included in the backup slides the references that you will need in order to find these reports. The first thing I want to say is that this plan that has been underway in Japan for many years, as well as Australia and Denmark and a few other locations, to have life cycle management is absolutely essential for protecting the climate. We all know that the climate is a crisis, it's out of control. We're experiencing terrible wildfires, storms, flooding, you name it. It's pretty discouraging. It has a lot of human consequences, a lot of destruction of property, and it's completely unnecessary because the changes that would protect the climate are often in the consumer as well as the national interest as well. And you all know that because you've been involved this for some time. In the case of life cycle management, you also know that all of the training, such as this workshop, and all of the tools that will be supplied from the Multilateral Fund are used for a variety of reasons. And I just wanted to highlight one because it's often overlooked, and that is that you cannot correctly charge refrigerant equipment with a gauge set alone. That in automobile air conditioning, they've proven beyond doubt that you need to recover the entire amount of refrigerant and then recharge according to the specifications, because there are just too many variables, temperature and altitude and the period that the system's been operating, whether or not the components are in good condition, whether the dehydrator dryer's functioning. So you get a lot better charge when you're able to manage the equipment with the tools such as recovery, recycle. And then of course, at the end of life, you want to recover this refrigerant because it's an asset and it's terribly destructive to the climate and the like. There's a business opportunity that we've been promoting for some time, which is what we call the early replacement of cooling equipment that was inefficient when purchased. Go back, yes, please. Inefficient when purchased, improperly installed and maintained for energy efficiency. So you actually have a better financial payoff replacing this old equipment recovering the refrigerant and destroying it, and then replacing it with the next generation. But of course, you need to have access to that equipment. I'll be coming to that. The kind of destruction technologies that were just described, whether they're local, whether they be cement kiln or other, are very important. You know that it's been very hard to destroy ODS because the permitting process takes a long time and it's difficult to stockpile the material and then comply with all of the rules of international shipment. All those things increase the cost. A simple technology like local cement kiln destruction costs far less. It has control locally and has local jobs and profits, and was just mentioned as part of a wider scheme to take care of a number of waste problems. And then finally, you know that there's a large effort at the Montreal Protocol by the Africa Group, stop the dumping of obsolete equipment. This is inefficient equipment with obsolete refrigerants. In the case of air conditioning, like R32 or R410A. Next slide, please. So this is breaking news, and I urge you all to study these documents very carefully. There's an organization called CLASS that has been working for many years on topics like minimum energy performance standards and access to new technology. And they've published a new report, which is listed in the backup slides, that documents the dumping in Southeast Asia of this inefficient equipment with the obsolete refrigerants. And of course, this is a terrible waste of money to buy inefficient equipment, and buying equipment with R22 and R410A surely will threaten compliance unless it is stopped, because this equipment has the lifetime much longer than the period, of course, for the HCFC phase out and for the HFC phase down. And we all know that these refrigerants become scarce and very expensive, and that an owner of expensive equipment might pay a large price, but that's again money that leaves the country. It's paid to outside advocates. The second report is a report that will be issued at the meeting of the parties. And this was a workshop that was held in Paris recently. And it was to look at the details of how a region can join forces under the Montreal Protocol to ask for shared responsibility. What we mean by that is that the countries that are receiving this obsolete equipment alone cannot stop it successfully. You all know the problems of the borders, you know the problems of loopholes, you know the problems of mislabeling the equipment, counterfeit equipment, and the like. And this goes into great detail and shows how the Montreal Protocol, through a simple decision in Nairobi this October, could change the way that an exporting country manages the sale of equipment in overseas countries. The idea is to not be selling in an overseas market products that have been judged unacceptable in the country, in the home country of the manufacturer. And you know that it's often the case in Africa and Southeast Asia that the temperatures are far higher and the cooling season is far longer than it is in the country of manufacture. So it's actually more economic, even than in the home country, to have highly efficient equipment. And all of the money that's saved on the electricity is spent locally and supports local jobs and prosperity. Many papers have been written about this. I'd be glad to work with any of you in assembling that for your own situation. Finally, we've had a very successful workshop underway for the shortest period of time, and we're issuing a report that makes it clear that there was a misunderstanding of destruction under the Montreal Protocol, and that simple technologies like cement kilns can be part of the solution for life cycle management. This will be issued in the spring of 2024. Next slide, please. This is an example from the CLASP report that shows the countries that were examined in Southeast Asia, and it shows the origin and destination. It shows the portions that are efficient and inefficient. It has later in the presentation discussion of the refrigerants that are offered. But you can see that it's an elaborate report that provides a lot of detail. And one thing I'd like to mention to you is that in some of these cases, it may not be strictly illegal to sell this terrible equipment into Southeast Asia, but it is certainly unethical, and it is certainly contrary to the declared policy of these multinational companies that they intend to be protecting the climate. So over the next while, through the Montreal Protocol and through all kinds of other international activities and social media and so forth, you're going to see these companies called out and asked why they would sell equipment that is as damaging to the climate when sold in Southeast Asia as if it were sold in their home country. So a company that's manufacturing air conditioning, claiming to be protecting the climate, is certainly untrue to that claim if they're doing this damage outside. And it's also true that the citizens of any country have a strong interest in having a level playing field for this equipment, equal access, and also affordability. So please study this report very carefully and bring this with you when you come to the meeting in Nairobi. Next slide. I just wanted to highlight one more thing, and you can study this on your own, but it is the case. You look on the right side there, the direct emissions. That's what life cycle management is mostly about, but it's also integrated with all of these other concerns. The refrigerants in its original manufacturing and processing and transportation has a lot of chances for emission. You know that when R22 is manufactured, it has unwanted HFC emissions that are very powerful greenhouse gases like HFC 23. And you also know that the electricity generation can be very dirty from fossil fuels such as oil, natural gas, and coal. And so that the effect of the air conditioner is much higher on a carbon footprint when the electricity is dirty and polluting from fossil fuels. So there's a lot of details that your countries are keeping in mind as they improve the quality of life and protect the global environment. You know that there are important details that are best done as a group. I'm very impressed with the work that's being done on the details of things like best practices for installation of equipment and new designs that are more suitable for the hot ambient temperatures. So I congratulate you all. Please look at the backup slides, and please contact me if I can provide any additional information. I'm sorry I'm not there in the room. It looks like a very productive workshop. Thank you very much.
Thank you very much, Stephen. I know, well, it's very early morning, well, in Washington D.C., United States, and I truly appreciate, well, your contribution to the seminar. So now I would like to entertain questions or comments for those two presentations. One from Kumprim and the other one from Stephen about the refrigerant destruction at the waste incineration facility or cement kiln. So can I, if you have any questions, please raise your hand. Okay. Mr. Tamida. Okay, you can introduce yourself.
Yeah, I have a question for Pauline-san. So thank you very much for your presentation. And also, tomorrow I'd like to see your facility. So I have two questions. One is, yeah, you presented your current destruction volume. That is about 50 tons per year. I think that is a very good number because we are doing the same project in Vietnam, but at the moment, our volume is just 1 ton per year, very small. So, and last slide you said that your challenge. So that means you will try to increasing the destruction volume. So could you tell us your targeting volume for destruction in near future? This is one question, first question. And the second one is, what is the most important issue? How to increase the volume of the destruction that are collecting the F-gas? What is the most important issue? How do you think? This is the second question.
Okay, can you hear me? Thank you very much for your questions. So about the first questions, what is our target? As a company, we have capacity something around as I mentioned, about 300 ton a year. So my target is to fulfill that capacity. So 200 to 300 ton is always our target. And we actually know that there's actual market of those in Thailand. So it's lead to the second questions. What is our biggest struggle to get those volume of the refrigerant is actually, as I mentioned, in Thailand, we already have regulations, especially the industrial park. To make you understand about this, when one factory would like to dispose any waste, they have to contact to DIW, Department of Industrial Works, and they have to register in the DIW system that they will dispose of this type of waste for how much volume and where is the final location, who is the waste treatment. Those everything of this information already been there in the DIW system, and even this system are there, but the problem is that the monitoring is of the refrigerant recovery is the problem, because when other waste leak, you can see the contamination. Like when the wastewater leak, you can finally clearly see the contamination of the wastewater. But in case of refrigerant, when it's leaked, no one knows about that. So I think the regulators still have such problem to control. That is the biggest problem, because most of our customer is actually Japanese companies who always work with refrigerant and familiar with those. So that's why they are very responsible to dispose those waste. So my biggest problem is I want to raise up those awareness of every users that this refrigerant have a big impact in greenhouse gas. And yeah, and everyone, maybe any kinds of incentive like carbon credit or anything that can help everyone work together in cheaper price. Everything is I know about the business, our income is everyone cost. So that's a kind of difficult, but yeah, this kind of system that everyone work together, the cost sharing system might be the answer in my idea. Yeah.
Yeah. Okay. Thank you very much. We are doing the same kind of business, same kind of destruction facility in Vietnam. So our targeting volume is about 130 tons per year. Otherwise, it's very difficult to get to the monetized business. But we will try our best to increase the destruction volume also. Anyway, thank you very much.
Same here. Yeah. Thank you.
Thank you very much, Tamiza-san and Prim. Are there any further questions? Okay, I have a question to Stephen. Thank you very much. So you briefly touched upon the report coming out regarding the cement kiln. And I also concur with you that, well, this is a quite effective solution package, a part of the package. And then maybe could you elaborate a little bit more, what kind of international cooperation arrangement could could be prepared, or can we argue for facilitating for the introduction of cement kiln and the destruction action? Do you have any suggestion in this regard to the colleagues who are here? Many of our colleagues are from national ozone unit of ASEAN countries, and then they're looking for our sort of like a productive, future-looking discussion among us with the Japanese government, but also with the international partners. So if you have any suggestions, let us know.
Yes, thank you very much for that question. First of all, I should explain that the idea of this publication was that there was a small number of experts that each had vital information that could be all placed in one location, and it would help explain to the parties of the Montreal Protocol how they can change the rules in simple ways to make cement kiln destruction more economic and more convenient for the national ozone units. So we resolved that part of the question, and then you're absolutely right. There's the question of how do we actually start implementing this? And one part, an appendix of this report, is intended to be best practices for managing a cement kiln, because there's important details that many people have known from their demonstration projects, but those are sometimes left behind. So there's questions of actually how do you adapt the cement kiln for the ODS and the HFC destruction, and then how do you meter the destruction along with the other activities of the cement kiln in order to make the costs as low as possible. We're also looking at simpler ways to have the benefits of the ODS and HFC destruction counted as part of the national commitments to climate, to be available for a local goal of carbon footprint reduction, so it doesn't require these international participants that each extract profit, and make it really into a routine, cost-effective technique that would be part of a national plan for the market transition. And then finally, just to emphasize this huge business opportunity to have an early replacement of this inefficient cooling equipment with obsolete refrigerants naturally produces a lot of refrigerant at low cost that would be available to a cement kiln. So you can imagine if you were replacing 500 air conditioners at university or a set of hospitals or something like that, you'd be able to have a dedicated worker that would recover the refrigerant at lower cost than when you're taking out one air conditioning and replace it with the other, and you have to wait for the recovery equipment. So there's lots of business planning that could go into something like this, where you'd have the first crew recover the refrigerant, and no one would wait for that to be done. So there'd be no downside to this. So I think what you'll find is a very pragmatic, very business oriented, and it really tries to draw together those business interests that have a lot to gain, as well as the public that gains from the climate protection. I'm very optimistic about this report.
Thank you very much, Stephen. Just wanted to share with you, earlier in this morning in Bangkok, we had several relevant conversation with among us, participants from Asian countries. One participants from Cambodia, from the Ministry of Environment, Cambodia. Well, they're actually looking at the possibility of working with the cement factories in Cambodia for a potential destruction of used refrigerants or unwanted confiscated refrigerants. And also, we've been working with several private sector companies, especially not in the fluorocarbons context, but I trust for example, cement companies in Thailand, well, they are quite advanced, and then very much famous for their leadership in environment integrity. So I think there are a vast potential for all of us to work on in this area. So I really appreciate your kind contribution to this event. Despite big time difference between Bangkok and Washington D.C. If you're still available, well, you can continue to observe or the rest of our discussion. Thank you very much, Stephen.
Well, thank you, and please send me any materials that would be helpful for the cement kiln report.
Okay. All right. Okay. Thank you very much. Well, that was the great presentations from Sure. Thank you very much. Yep. Okay. Great. Then, so let's move on. Well, we're going to have the final part of our discussion on the day one, which is going to be covered by Mr. Kasai again.
Thank you. Could you connect it to this seminar, Mr. Anderson? I'm Kasai. I explain destruction technology, including cement kiln. This slide is used to 22 fiscal years this seminar, and some part is revised. Next slide, please. Yeah, I emphasize I emphasize consumption zero is not mean emission zero. There are leakage and emission after discard. And one destruction facility, Mr. Pri and Tamida said 100 to 150 ton is a capacity. Then it is necessary to systematically set up destruction. Also destruction facilities, also a reclamation facility. This is said Professor Dung 2 years ago. We association would like to know how many destruction facility each country will need, because it's necessary to organize feasible support scheduled between relevant companies. Before I said thanks letter is an initiative for a Japanese private company, and it is a point. Destruction is a reduce of emission, but reclamation temporary avoidance of emission, because deferred fluorocarbon would be leak or wouldn't be collected. But our association made network considered income or sales of reclaimed fluorocarbon is the most feasible fund for incentive for collection operator and destruction cost. This is this destruction method, mixed destruction method equipment. The merit is cost is cheaper, about 4 to 5 million yen. The efficient operation can be performed if fluorocarbon are collected to the systematic setting up facilities necessary. The destruction cost including installation cost, durable years, labor cost, fuel cost, and the amount of fluorocarbons received, etc. These costs was a stock for cost of stock then average it turn to destruction cost. Also, the environment value of reducing greenhouse gas emission is very high. The destruction of fluorocarbons do not produce the economic value unless getting destruction cost in advance or economic incentive requisite, that the destruction business cannot continue. In fact, some destruction facility were installed overseas with Japanese support. They were not to be used after end of the demonstration project. A bad example. There's a two type of destruction method. It is a cement kiln dedicated to destruction method equipment. It is small equipment 40 million yen. Large equipment is 100 million yen. 2 years ago. It is a point of each facilities. Cement kiln, fluorocarbons are decomposed and no waste is generated. But the contamination rate of chlorine in cement under 350 ppm. Check is required. The waste incinerator, appropriate treatment of incinerated to ash is necessary. And it is necessary not to lower the conversion temperature. It's necessary over 850 degree of Celsius in consideration what binds together. Mr. President. This is a Japanese destruction system. The battery shorted. Could you hear? Japanese destruction system is a permission system. Then there's a standard of the ability of destruction, a structure standard, and a standard of use and management. Then I skipped this is component of the record and report. This report submit to local government. The certificate of destruction issued by operator. It is an overview of Japanese law. Excuse me, could you open my last session slide? I would like to explain cost recovery. Thank you. The review ね。Japanese system, home appliance, commercial use, and automobiles. Then I listed alternatives. Then I would like to explain a theoretical background. User charge. The user charge, for example, automobile. There's a theory of one-to-one payment. User should pay the cost of his own car. The pay at discarding appliance. Some person dispose used car without paying disposal cost by illegal. It's this type push to illegal action. The deposit. Before regulation started, there are a lot of cars in use were bought. These cars are not paid the disposal or recycling cost. How to collect these costs is a big problem. Then other theory, collective user charge, balancing total cost and total payment collectively. The precondition, sold car stock 70 million, new car 6 million per year, discarded car 5 million per year, export of used car 1 million per year, collection and destruction cost per one car alpha, shared cost per one person C. They should pay only buying a new car. So only buying a new car. It is not correct from using or used car. The one case A, automobile air conditioner are all new car. Don't use fluorocarbon in 10 years. 6 million 10 years and C.で、括弧、70 million plus 6 million かける10 years、multiple 4 million、divided 5 million multiple alpha. The C is 1.73 alpha. The B 20 years. C is 1.26 alpha. The fluorocarbon used car will be sold. One-to-one payment, it is not necessary. The next case, extended producer responsibility. The manufacturers internalize these cost in product price. It is a key concept. Manufacturers should bear the disposal cost in the future, including advanced sold card. Each amount of income is separated as reserve fund, non-tax from profit. Manufacturer can keep reserve fund without tax. The levy on import. Levy on import raise the price of imported fluorocarbons. Then price of reclaimed fluorocarbons will be cheaper compared with imported fluorocarbons. And the revenue of levy will be used for incentive for collection operator and destruction cost. Furthermore, raising fluorocarbon price to promote leakage prevention. The credit requires a lot of data and procedures. It is now only a potential. Donation. This company paid ODS destruction cost thanks later. Last our proposal. Our member country can scribe CS report our contribution. Now we use our network used to income or sales of reclaimed fluorocarbons. So just to complete a little complicated to explanation. Then now our network adapt to this type, and if your country give us thanks note, we collect the we would like to collect donations. Not only our member company, but also brand company or relevant persons. Thank you.
Thank you very much. Thank you very much, Kasai-san. I think what this is nice layers options for establishment of financial arrangement to support refrigerants collection destruction. So I think we're going to come back to the discussion, and just to in this late afternoon, we have Kun Pompron here, who is the policy advisor on the environment to the governor of Bangkok, and then he needs to leave very soon, but I would like to have him introduce a little bit about what the Bangkok Metropolitan Administration doing in terms of climate change. So, please. Yeah, sorry about this. Yeah.
Okay. Sawasdee krap. Good afternoon, everybody. Hope you are doing well and had a productive day today. So I'm glad to be joining your session today. So thank you very much for the invitation. So as mentioned, introduced by Kun Kato. So I want to briefly share on what BMA or Bangkok Metropolitan Administration is doing regarding climate change mitigation. So admittedly, on the fluorocarbons, we're still, not as prioritized as the carbon dioxide and the methanes, etc., which we believe are doing quite a lot already. So just want to give an overview that overall in Bangkok as a city, we produce around 40 million carbon tons equivalent per year. So around 60% is from energy use, either in residential, industrial, or commercial, and 25% or a fourth is from transportation. The rest is from wastewater, etc. So we already have a climate change master plan, which our goal is to reduce our carbon emissions from business as usual, so 19% by 2030. And we have a long-term goal to be net zero in 2050, and 15 years before Thailand's national target, because we may not have agriculture as much as the rest of the country, so we can afford to be 15 years earlier than the rest of the country. So as I mentioned, a lot is from the energy side. A lot of policies are trying to gear towards, encouraging buildings, especially private sector, to focus on renewable energy and energy efficiency. BMA alone, we are local administration. We do not, have the authority on, power production and, grid management, but we liaise a lot with the relevant agencies and also the ministries in charge. But also one thing that we can do right away, which we're already doing, is to make sure that our own assets, which we have a lot throughout Bangkok, is as clean as possible. So for example, we have 2 city halls, 50 district offices, we have 437 schools, 10 or so big hospitals, and 70 smaller clinics, etc. We have a lot of assets. So the governor has a policy called BMA Net Zero, which is to firstly calculate the amount of emissions that is emitted by the BMA assets, and have a reduction plan to help mitigate this. For example, we plan to change a fleet of our garbage collection trucks into EV. This is a big and progressive step that we are currently pushing for, and we are working with the energy agency to install solar panels on our schools, our wastewater treatment facilities, and our city halls as well. So that's going well, and the governor has big plans to change as many of the street lights to LED as much as possible. So again, I came here today, I learned a lot, and I think there are many more things that we can do, for fluorocarbons and how to reduce emissions from this source. But so starting from CO2, methane, and also the governor places a lot of importance on waste segregation, because we spend a lot of money on waste management, and also, if we can remove waste that are going into landfill, then it helps with the methane reduction as well. So just a brief overview on Bangkok, and I hope you a successful event tomorrow as well, where you'll be visiting the site. So thank you very much. Yep.
Thank you very much, Kung Pompron, for I just actually abused my friendship with him to request for this this. But as you know, well, everybody loves Bangkok, right? So whether you're residents or you're from Bangkok or you're visitors from Bangkok, but I think this city is. Well, well, it's now demonstrating very dynamic process towers for the decarbonization and net zero emissions towards 2030 first of all, but 2050 And we are very much encouraged to see colleagues for here actually already introducing for actions rather than only planning or discussing, but now his governor or our governor is already introducing many different new type of action. So I hope our group can also join to his force. Of course, we were talking about fluorocarbons, but this is essentially related to energy efficiency in a larger context, and also cooling is actually very essential part of the life of Bangkokians and also Asian people. So that this is something I just wanted to entertain his additional valuable speech to this event. All right, so with this, I think we had a really rich discussion today, and perhaps we would like to invite colleagues who have participated in this event. Anything you want to add, or you want to share, or you want to question? Maybe now you realize probably we're still at the daunting thing, but starting with maybe yeah, country. Okay, so maybe it's not always fair to start with ABC, but there also maybe we can say XYZ. So which is I think no B is actually then okay. Maybe my friend from Vietnam, Yun, and also Nam. Maybe can you reflect your kind of impression about today's discussion, or anything you okay.
Yeah, I just want to thank you because this was so informative for us at the representatives from countries. So I hope that in the future we will have more workshop like this, or even dialogue between the countries in regions, that we can have more exchange or update to implement effectively and productively the Montreal Protocol. Yeah, that's all. Thank you very much.
Thank you very much. Okay. Maybe I am coming back to him later. to Yun. Okay. My friends from Kung Oranut, what from Thailand. Do you have any comments or anything you want to share? Yeah.
Okay. Thank you, participants. I saw the lecture, but Thailand not have calculate calculate fluorocarbon. Is report inventory and GHG reduction assessments. Today I have saw the official data to develop fluorocarbon in the policy in Thailand and divert to target NDC Thailand.
Thank you very much. Yes, thank you. Thank you very much. Especially for the many countries just at the beginning stage of the development of HFC's national greenhouse gas inventories in many countries here. Well, we haven't done yet. Well, Japan has done, but countries like Indonesia, well, Dr. Retono and also Ibumeira, well, their group just, you know, sort of like made a very challenging start to with a view to development of the first HFC inventory. And I think I don't know which countries are more challenging with Thailand and Indonesia. I think both, both. But I think what we can do here is that, well, we have a really good case now, and then we can share the experience of Indonesia. We are still like maybe 30%, 40%, but this year and next year we're going to be maybe 50, 80%, 90%, and 100%. So that that's something your friends, your sister will be sharing the really good first assets of HFC inventory to Thailand. So I think what this is the beauty of this group approach in the Asia Pacific. Yeah. Thank you very much. Yeah. Okay. My friend from Mongolia. Yes, please. Sure.
Can you repeat your question?
Okay, so what did you learn in this event, and then what are expectations in future, or any requests to our friends?
I'm expecting to gain knowledge how to meet the recovery to any standard, and also also the Japanese experience of the rational use of Fluorocarbon Act, there which how to collect the recovery and how to transporting the recovered refrigerant. Yeah.
Okay. Thank you very much. For I will ask Watabe-san here, representing for the government, to also work with the with the Mongolian government. Well, the Ministry of the Environment is closely working with the Mongolian government through the joint credit mechanisms, or with the in terms of the fluorocarbons, through the Asian Development Bank ADB project. So that I think that's something we can we're hopeful in pursuing for further activities. And I think thank you very much for showing your expectation for the further sharing of act on rational use of fluorocarbons. Yeah, thank you. Okay, and Malaysia.
Okay.
Rina-san.
Yeah, thank you for the sharing session, especially for life cycle management, since this one of the Malaysian focus for Kigali implementation plan starts next year. So we hope we can share more and learn from others country and Japan also. Yes.
Thank you very much. Yeah, with Malaysia, well, E&D Solutions is actually engaged in this work, and then also bilateral. It's one of the very successful country for the bilateral cooperation. So I hope through that bilateral cooperation, yeah, we can further pursue the tangible products. Okay, thank you. And Monica probably is left, probably. Maybe not. Okay. Then my friend from Maldives. Okay.
Thank you. So I think we have gained some insights about the
end of life cycle for fluorocarbons, which is pretty important, especially in the Maldives. But I think compared to other countries like Malaysia or even in Thailand, like the volume of the fluorocarbons and even the appliances in Maldives is quite low. So I guess we haven't had a focus on the end of the life cycle so far. But as of now, like we don't have a standard or set procedures on how to deal with the appliances or the fluorocarbons. But with the help of ADB and World Bank, we are currently running some waste management facility projects. So I hope, like, let's say in the next 3 to 5 years, we can at least have a set standard of procedures on how to deal with this.
Thank you very much. Then you're returning to this table to introduce for your established standard to share those with us for in future. Thank you very much. Okay. Okay, thank you very much. Now, Indonesia, we have 3 people.
Thank you. I think, as anyone here already say, today's discussion has been very informative and also comprehensive. As for me myself, I think, however, it will become a big homework to learn how to explore more in the connection between the Montreal Protocol implementation and the UNFCCC. Especially on how to address it into fair regulation for all stakeholders, I believe, as well as to explore collaboration between the stakeholder, especially Indonesia for collection, recovery, reclamation, and also the destruction. Because I think we already have the infrastructure in Indonesia, but we still need to optimize how to make it all work together to achieve our goal. Whether in Montreal Protocol and also the UNFCCC. Thank you.
Thank you.
Maybe Ibu Mera or
please,
Ibu
yeah.
Gilang.
No?
Okay.
Okay, thank you very much. Hi. Now, Mr. Chapel from Cambodia.
Thank you. Fair deal. The Cambodia start first and now at the end for common. This is, I think, I personally think this is important event brought by OACC in Japan for us to meet and learn. And I personally thank you for presentation, and I hope that what we have learned today and tomorrow will be brought back, especially Cambodia. Interestingly, for the inventory, HFC inventory that Japan has finished, and Indonesia is in the halfway maybe, and Cambodia maybe at the starting point. And we will learn from your experience. And in terms of HFC inventory, and also for destruction or recycling and reclamation of HFC, that one of our concern, and our capacity and finance and facilities, as an example, are still limited. And frankly speaking, support from OACC in Japan previously is really important, and we hope to have more collaboration, and we'll bring the success to each country, Cambodia as well. Thank you.
Thank you very much. Okay, and then our key experts. Anyone? Yun? Okay, yeah, go ahead. Okay.
Yes, okay. Thank you, Mr. Kato, my best friend. Okay, so ladies and gentlemen, first of all, I would say thank you very much for your workshop, and in the workshop, the college, I have the first time to meet, and some colleagues I have the times. Okay, but I think that for the workshop we can share some information, some knowledge, and very important in the experience from the country. Okay, so in today we are from Vietnam, so we learn together from country like Cambodia, like Mongolia, Malaysia, Thailand, and so on. And I realized that for the management, HFC or refuse by life cycle is very not easy to each country. Okay, so it is very challenge, except in Japan. In Japan, I know that you are very experienced, but Mr. Kato and some colleagues told me that in Japan there is some challenge to management. So in my presentation in the morning, I would mention that for a cheap sustainable cooling, we need to consider life cycle management of refrigeration and energy efficiency. It is two aspects for cooling. Okay, so once again, I would say thank you and have you a good, nice evening and nice party. Thank you very much.
Thank you very much.
Yes, thank you very much.
Anyone experts for here? Asai-san, you want to say something? Yes. No, thank you. No, thank you. Okay. Yeah, you have talked a lot. Watabe-san, would you like to say something? Maybe. Little bit. Okay. Little bit. Okay. Yeah.
Yeah, so thank you so much for coming this seminar and sharing the experience of each countries. So as a Japanese government, so today I could know each situation of each countries. Yeah, of course, Japan and OECD would like to support the countries to reduce HFC emissions now in futures, now and futures. Thank you so much today.
Thank you very much. Yes, with the support by the Japanese government, this time, it's been kind of like a fourth time for the series, but the first time in the actually the face-to-face event, and then without their support, well, it was very difficult to organize this event. And also, I really want to thank for the experts here, experts basically who traveled from Japan and also from Thailand. My friend for Assis-san, well, you traveled from Hyderabad on the but also this is our common assets with experts here. Of course, for the governments, government officials, well, you are playing a very important role and key role, but also experts for in companies, consultancy companies, also engineering companies, also trading companies, so in many different sectors. I think this is important thing. And then, well, you see life cycle management of fluorocarbons. It's quite complicated, but also this is the benefit of having for this kind of ecosystems. Yes, nobody can do this business alone. I think in partnership with different stakeholders, well, this is quite important in these areas. And again, well, the cooling, whether fluorocarbons management, ozone layer protection, whether climate change, for energy efficiency, well, this continues to be our vital service in our sustainable life. And I think you're the one who can actually drive us forward in this area, especially in Asia Pacific region. So I hope this event has been a bit meaningful for your future work. And also we are willing to bring things in actual fruit. Yes, not only discussion, but also the action is important. And then the further actions, well, to initiate our further actions, I would like to suggest for our event program, which is a networking reception, which is going to start at 6 o'clock for dinner. Yes, so that all of you are cordially invited to the first floor, which is the room in front of the lunch place. So you are cordially invited to Ratanakosin. Ratanakosin. They're difficult in Thai language, but you're cordially invited for and then this is a very easy eating drinking party, so that yeah, if you want to go out for shopping, well then after that you can go out. Thailand, Bangkok is a a very nice place, but I hope we can further strengthen our friendship. So with this, thank you very much. And also before finishing, tomorrow we are going to go out for a site visit. And then it's a little bit far from Bangkok, so that our bus leaves at 7:30. So you're probably it's nice if you have you on the ground floor, first floor, maybe something like a 7:15 or 7:20 at the latest. Yes, and then if you miss your breakfast, well, we have some sandwiches or something or drinks, so that if you want to skip breakfast, it's okay. But anyways, well, if you don't forget, well, let's move on to the networking reception. Thank you very much for your hard work today. Thank you. When you come to the reception, please bring this for admission.